Hello everyone and welcome to this new session in which we'll treat dataset versioning with weights and biases. If you've already used Git for code versioning, then you should note that this is kind of similar to what Git does. As here we have this original data. Let's take this off. We have this original data, which is then pre-processed into this data here, and then this other pre-processed data, or this pre-processed version, is again pre-processed to give us this one. And then finally we have this last step, or this last pre-processing step, which gives us this dataset version, which happens to be an augmented dataset version. So this shows us that if at any point in time we aren't satisfied with this pre-processing which was done right here to produce this dataset version, we could simply pre-process from making use of this dataset version right here. And so this greatly simplifies our dataset management when working in our different machine learning projects. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. Just as Git permits us do code versioning, weights and biases gives us the possibility of doing dataset versioning and model versioning. And this can be done using weights and biases artifacts, which help us save and organize machine learning datasets throughout a project's life cycle. We are going to start with the dataset versioning. And the most common ways in which weights and biases artifacts are being used for data versioning are to version data seamlessly, prepackage data splits like training, validation, and test sets, iteratively refine data sets, juggle multiple data sets, and finally visualize and share data workflow. Before getting into seeing how artifacts could be used in dataset versioning, let's look at this simple example. In order to obtain the malaria dataset, we have to start by loading this data. We have this data loader, which is represented by the square. And now once we've loaded this data, we have our data set. So let's say we have this original data set right here. We now go ahead to split this data. So from here we can split up this data and then have the three different parts. We have the train data, the validation data, and the test data. At this point, all three data sets are now been passed in this pre-processing units right here. So we pre-process the train, pre-process the validation, and pre-process the test. And this gives us an output here. So for the train, we have a pre-processed training data. Here we have this pre-processed training data. We have this pre-processed validation data. And then here we have also this pre-processed test data. Again, at this point, we are now going to carry out augmentation on this pre-processed training data. This PTRD means pre-processed, this pre-processed training data, and then pre-processed validation data, pre-processed testing data. Okay, so we have that, and then we pass this through this augmentation process. So we have this process whose role will be that of carrying out data augmentation on this data set to produce another data set, which is actually now an augmented version of this. So here we have pre-processed training data. Now we have augmented training data. And this is kind of like the life cycle of our data set in this particular problem in which we're working on. Imagine that this original data set contained mislabeled examples. In that case, what you want to do is now to carry out this labeling correctly such that we have this data set here, which now has been cleaned. Overall, this leads to a high level of accountability, as when working in a team, and let's say you've done some modification, let's say you have cleaned the data, other people in your team can now view this cleaned data set and decide whether to modify it, delete it, or keep using it. So if we suppose that the team accepts this cleaned data set and everyone is happy with this newly cleaned data set, we now see that instead of passing this directly into the split, we will now pass but this one into the split. So we would have something like this. We'll go this way. Let's take this off. in that case, we would have to go this way. We go this way, this, and then into the split. And then talking about dataset versioning, for each and every dataset we've created here, like for this one, this, or this one, we have different versions. So we could have, for example, this PVD here, that is the pre-processed validation data, and it could have a version 0 or version O. So we have the version O right here, and then later on you may modify this pre-processing, and it leads us to have another version of this validation data. So you could have another version 1, and the version 2, and the version, you could say version best, you could have version latest, and so on and so forth. And a good thing is, when weights and bias, or when using weights and bias to store this data, or when we using weights and bias artifacts, the data is stored in such a way that if we have data in this original data set, which is exactly the same as what we have in this pre-processed validation data, then that data wouldn't be duplicated. Now it's true that if we pre-process this data, obviously we'll have all the data set, or all the elements of the data set changing. Now let's take this example for the cleaned data set. So here we have this original data set. Let's suppose we have 10 different examples, different samples in this original data set, and then after cleaning our data set, only 2 of these samples have been modified. So we have 8 unmodified and 2 modified. So we have changed the labels of these 2 samples here. What weights and bias will do is it will ensure that this 8 here aren't duplicated. That is, we don't create extra space for those 8 others which haven't changed from this previous original data set here. And so in that case, we're gonna only store this 2 new samples here, while weights and biases keeps track of the fact that this other 8 samples haven't been modified, and so don't necessarily need to occupy extra space in the storage unit, which weights and biases makes available for us for free. That said, we could look at those different processes right here, those processes in the square boxes, as WandB runs, while this different forms and even the versions which our data takes are the artifacts. And so we could consider this key here, where this represents the artifacts and this the runs. Also, we see that the artifacts are connected together by these different runs. So these 2 artifacts, this training data and the original data set, has been connected together by the split run. And then this 2 PTRD and train data are connected together by the pre-processing run. Getting back to the documentation, we'll see how we create this artifact here, which is called the new data set of type raw data, and then this is created within this run right here. So we see how we create this run, and we specify the project, my project, and once we create this artifact, we're gonna add data into it. Now, one thing you could do with WandB is you could simply add a whole directory. So we're supposing that all your data is in a given directory, and so all you need to do is specify this path, and then you make this data part of this WandB artifacts, which we've called my data, and then finally you log this artifact to WandB. Let's copy out this sample code, paste it out here. We have that sample code, and then we could get started with our dataset versioning. Now we are going to put this in a with statement. So we have here with WandB in it, and then we'll specify the project we're working on, which is this malaria detection project, the entity neural learn, and that's it. So we have this here, and then we are going to create our original data. So we have original data. There we go. We are going to create this artifact. Actually, we have that original data, WandB artifact, new data set type raw data. Now to check out on the different arguments we could pass in here, get back to the documentation. Let's check out here, and then you could scroll down. So here you have this references. Let's reduce this and have this clearly. We have references. On the references you have this Python library, and then you have WandB artifact. So you could click on this, and what do you get? You have this documentation right here. So we have the different arguments: name, type, description, metadata, incremental, and use as. Now note that this for optional, so that's why in the example we just had the name and the type. We'll now add up this here. We have name and then type, and we have description with a metadata. So let's have this description right here. Description, simply we could say malaria dataset or TensorFlow malaria dataset. So that's it for the description. It's actually a string. And then we have this metadata, which is this dictionary which contains information related to our dataset. So here we define this dictionary. We're gonna start, for example, the source. So we could have your source, and then we'll say TF dataset. Okay, so we have that source. We could also add other information from this home page. So let's even copy out this description here and then paste it out here. So in the place of this description, we have that, and there we go. That's fine. Now we'll check out on the home page. We have home page source code. Let's copy this out and paste out here, and now we have all this necessary metadata information. So here is it. We've created this artifact. We then paste out this code which we had seen previously, and which permits us load the malaria data set from our TensorFlow data set, and then we'll save this data set in the NumPy compressed format. So with our original data, which is this one here, this artifact dot new file. So unlike here where we add directory, here we add in we're creating this new file which now contains this data set. So with original data dot new file, we'll call it original data dot npz. So that's our file name, and then the mode is going to be a write mode, and we have this as file. So we have this artifact, we add this new file with a file name, and then we save this file while putting in the appropriate content. So right here we have np save z. That's our compressed format. Here we have npz, and then here we have this file, and then what we pass in is our data set, which is this one. And so at this point we've written information or this data set in this artifact, and then we're now ready to log this. So here we have run.log artifact, this basically this here. So let's do this. Let's take this off. We have, there we go, we have run.log artifact, and then what we're passing in here is original data. Okay, so that's it. So now we've seen how to create this run, and in this run we have this artifact, and then we put in the information in the artifact. Now one thing we could do is put all this in a method. So we'll define the method load original data. So we load the original data, and simply that's it. So let's send this one step, and that's fine. There we go. So we have that load original data method defined. Let's add this code cell, and then we can call it right here. So we can call load original data, and there we go. So let's get back to this diagram we had previously. You'll see that in this diagram, if we take off, if you don't consider this path, that is information flows this way and then gets split and so on and so forth. So here what we have is we've had this load original data method which takes into consideration this two. Here we have this run, which is the data loader. So we have the data loader run, and then what it does is it recuperates this original data set from TensorFlow data sets and then produces an artifact, which is this one now. So the artifact we have just created here, this artifact original data, is this which we had drawn previously here. We then run the cell and load the original data. We get this output. Unfortunately this process has failed. Let's check out the reason why this failed. Cannot convert a tensor of d-type variance to a NumPy array. Now, since this variable dataset we have here is of the type variant, what we're gonna do is we're gonna take out each and every element of this dataset and save it in a directory. So from here, we're gonna copy out this code. Let's copy out this code and paste it out here. Click back. And now what we're having here is we're gonna go through this dataset. So we have for D in dataset, or for data in dataset. Now we have a list here, and then we could pick out the 0th element. So pick out the 0th element, and then for that we are going to create this folder dataset right here. So let's have this new folder and call it dataset. Okay, so we have that new folder dataset. In that folder dataset, we are going to put in this different tensors which are going to be stored in this NumPy compressed format. So that's it. We have this. We'll modify the name. So let's say we have malaria data set, and then we give it a number. So let's have that plus, we'll give it a number plus this. So here now we have this k, we've initialized k, and then we're going to continually be incrementing this k. So here we have now malaria data set, we have k, and then we have this extension right here. So that's how we're going to save this file, and then the data we're going to be saving is going to be this. So we have data which we're going to be saving in each and every one of this file. Now let's test this out, and let's put out a break here so we see exactly what we'll be getting. We run this cell, original data not defined. We instead need to do open here. So we're going to open this file and then save that. Let's run this again. We check out now this directory. We have your data set, and there we go. You see we have this information here saved. Now let's run this for all the data set. So let's take out the break and then run this. Let's print out k, and then like after 1,000 steps. So if k modulo 1,000 equals 0, we should print out k. Okay, so let's run again. We have now all this data locked. Let's take off this one now, and then get back to the documentation, and you have my data.add directory dar. So you pass in the directory right there. So from here we have now instead original data.add directory, and then we're gonna pass in the directory, which in this case is dataset. So we have that dataset passed. We don't really need to have this again, so we could take that off. Okay, so that's it. Everything looks fine. Let's now run this cell right here. We run that and run this, and this time around the artifact is loaded successfully. So now we are going to check out in our dashboard, and here you see that we have this raw data, new data set, and then you have this versions, 2 different versions of this new data set. We have version 0 and version 1. Now you click on this version 1, you should be able to have this. Let's check out in the overview. You see you have this data set, malaria data set on all this. In fact, there's a metadata we put in already. So that's it. We have this API. We're going to come back to this actually, because to use this artifact, we'll be making use of this API. Then we check out on metadata. We have this metadata which we logged in, or which we put in the notebook. We have the files. You see those different files here. This directory, you see you have the root, and then you have basically all those files. Now you have this graph view, which for now is very simple. So here you have a run. The run is actually this run here. So this run, and then we have this artifact which has been created. Now this artifact contains the raw data, and so we could click on explode, and basically that's it. Here you have the name of this run, vivid water, the name of the run, and then the data is this new data set, and it's version 1. And then the next thing we want to do is to move to the next step, that is be able to split this data set into this 3 different parts. Now what we could do other than this is pre-process this before doing the splitting, so we don't have to do this pre-processing twice. So instead of having this, let's take this off here. We'll modify this such that here's what we now obtain. So coming back to this, we have this run and this artifact, which our raw data set is basically what we have here. And then the next step will be to pre-process this. So we'll do the pre-processing on our raw data set, and then produce this pre-processed data. And then from here, we will now do the splitting. We'll have this run, whose role will be to split our data into the train, validation, and testing. And then for the train, we'll have another run, whose role will be to do augmentation on our training data. So in fact, in summary, this is what we want to achieve. Like when we're done with all this, we want to have a graph view which looks like this. We now go straight forward into the pre-processing. Now it's copied. We get back to the code. That's fine. We paste this out here. We then put this in the wait statement and then run this code, and here's what we get. We've now downloaded this 27,000 files. We check out here, and we should have this artifacts, new dataset version 1, and you see we have all those files which we logged in previously. So now this means that the next time you want to work on this dataset, you don't really need to come and run this here. Like, we don't need to run this again, so we don't have to do this again. All we need to do now is just to use this artifact which weights and biases stores for us. And so now that we have this, we'll get back here and then redo this resize rescale. Practically our pre-processing here is resizing and rescaling, so we're gonna do a resize and a rescale of all our images. We can copy this and then get back to where we actually have loaded our artifact. When we print this out, we have this path to our different files. So we could have your artifacts. We can check out all those files here, and then right now we're gonna create this other run. So let's copy this out and then have this pasted here. Now here we have this pre-process the data. So this is this method we're gonna be defining. WandB init project entity as well. We've created this new run, and then we have now this pre-processed data, which is now this new artifact, and the name is pre-processed dataset, and then the type is pre-processed data. We have our pre-processed data. Okay, description would say a pre-processed version of the malaria dataset. Let's take this off, and then for the metadata, we could let's take all this off. Let's have this taken off. But you could always put information at level of metadata. We are now going to go through each and every file we have in this directory here. So we will have for file in, let's say for F in os.list dar of this directory here. Let's copy this from here. So we're gonna create a list from this directory, and we go through this list. So we go through this list, and then for each and every file in this list, what we'll be doing is open up that file. So here you have artifact directory, which we've just defined, and then we have this artifact directory plus F to specify the current file, and then we read that file as file. So from here now, once we've read this as file, we have XY outputs. We call this our output. So for each file, since each file we had has an X and a Y, we'll take this from here, and then we have this load file. Now once we have this, we're gonna have X, or better still X full. That's X dataset. Let's call this X dataset, or dataset X. So we have our dataset X dot append. We're gonna create this as a list. So we have your dataset X, a list, and then we have dataset Y, another list. So that's it. We've created these two lists, and then we want to take each and every element and append it to this dataset X and dataset Y respectively. Here we have for X, and then we have dataset Y that append Y. Now recall what we have to pre-process, as this is our pre-processing method. So here we have this resize. Let's make sure we run this resize rescale, and it takes in the image, or it takes in X basically. So here we have resize rescale. Instead of passing X, we'll do resize rescale, and then we pass in X. Now we ensure that we define this im size. Let's have this im size defined here. Im size equal to 24. Run that again. That should be fine. We need to also specify the fact that we will allow pickle here. So we have this argument which is turned to true. You could always check out in the documentation right here. And then from here, we are not going to take this directly. Yeah, what we get is npz array, and then to obtain x and y, we have x and y, which is equal npz array. We get the numpy array, and we get the values. So that's what we do to get this. You could always check out documentation to understand how all this np load and all of this work. Now once you have x and y, this is what we pass in here. So from here we can run this. This looks fine. We have our data set, and that's okay. But before running, we have to ensure that we convert this now into a TensorFlow data set. So let's get this done by having this called dataset, and we have tf data set from tensor slices, and then what we're going to pass in here is dataset x and dataset y. Now we're going to be saving this as a file, so we're going to take out this, and we have this portion of this code right here, which is going from documentation. So here we have with artifact, the artifact here is pre-processed data. So with pre-processed data, the new file, we specify the file name. Let's call this our pre-processed dataset as file. We then save this with numpy. We have np.save z in the compressed format. We specify the file and the data to be saved. In this case, our data is this dataset right here, which is this TensorFlow dataset. This looks okay. We can now do log artifact pre-processed dataset, or rather pre-processed data. Then before running, we are going to take out just a part of all this data set. So we'll take out only 1,000 elements. And the reason why we're doing this is because we do not have enough memory to store the 22,500 different data points as a single variable. So we'll have that for now. Let's have this 1,000 elements so you could see how this is done. Now, if you have a real world problem where you have, say, 100,000 different elements or 100,000 different data points, then you could break them up into simpler parts. So here we have that 1,000. We take out just 1,000, and then one thing we'll do is copy out this part here. We'll copy out this part and then include it in this run. So just before this, so we include this here in this run. And the fact that you include this in this run will link up this new data set with our pre-processed data set. Now that said, we could run this and then run the next cell. What we get is this error saying cannot convert a tensor of D-type variant to a numpy array. So here we are having this tensor of D-type variant, and we're trying to store it as a numpy array. And to solve this problem now, what we'll do is we'll just ignore this and then save the dataset x and y as this list. We have dataset x and dataset y. So let's run this now and pre-process our data. We now have successfully logged this to our artifact. Let's get to our dashboard, WandB dashboard. Let's refresh this page. Here you'll see your artifacts. You could click on artifacts, malaria detection, artifacts, and then you could select from this. So this is what we had previously, this new data set under this raw data. Now our pre-processed data, we have this pre-processed data set, and this is our most recent version. There we go. You could check out the files. You see this file right here, metadata API, which you could use now to do or carry out other operations. The overview, graph view, this our graph view right here. Now let's explode this graph view. Okay, we have exploded this graph view. Let's zoom. Okay, Now you'll see that, let's drag this one here, and then what you'll notice is we have this first part which has to do with the creation, or rather with the loading of our initial original data set. And then once we load this original data set, the next thing we did was to now pre-process this data set. Now we carry out other runs previously, that's why you have this, so you don't really need to take this into consideration. From here we just continue from this point here. We copy out this API here, we have that copied, and then we get back to our code where we're gonna start now with the data splitting. Spaces out here, you see that we're gonna have we've already had two artifacts created. One was original data, the other the pre-processed data. The next will be the train data, validation data, and test data. And so that's why we call this section the data splitting. We'll again copy out this part from the pre-processing data and paste here. Now we have this. Let's go ahead and take this off from here and then replace this one here. We have this artifact. Okay, we have this artifact now, which is the artifact we're using now is preprocessed data set. And then from here we have three artifacts which we're going to create. We have train data, we could just call this train data set, type, let's say it's preprocessed data, description training data set, and then the artifact directory we could get it from this here. So when we create this artifact, we're gonna get this artifact directory. For now, let's just create the other artifacts. So we copy this out, train data, we have validation data, and then the test data. To obtain the artifact directory, we're gonna run this. We have this output here. Click on this artifacts and see we have this preprocessed data set which has been loaded, and we have our prep dataset.npz file here. So this here we copy this path, and then at the place of this artifact directory we're gonna place this path. Let's take this off. We have this path now which has been placed. We have now the artifact, let's call this artifact file, and then let's paste this out here, take this off, and there we go. We've now taken all this off. Okay, so we have this here, and then we're gonna have our artifact file instead passed here, artifact file. So we read that as file, and then we're gonna load this file, allow pickle, and get the array. Then at this point we define the train split, val split, and the test split. From here we're gonna paste this out. We have our train array, because we're trying to create this three different arrays. We have train array, which takes values from 0 to the train split. We define a data length, which is the length of array 0. Now recall that the array we're having, this array is at least actually made of two parts, the x and the y. This x has a length of 1000, the y a length of 1000. That's why we're doing array, the 0th index of array, and then we're taking its length. So here we're gonna get data length to a value of 1000. And once we have this data length, now we're saying that we're picking out this x, right here, and then we're taking values from 0 to 80% of the total length. And so we have train split, which is 0.8 times data length. So that's what we have. And then we repeat the same for this y. Then for the validation array, we're going to start from this train split. We're going to start from here times that. So from the 80th index with respect to the total data set, that's why we're multiplying by the data length. We're going to go from here right up to the train split plus the validation split. So now we're going from 0.8 to 0.9, and we have that set. We'll just repeat this for the validation for the y right here. So let's copy this out. We'll copy this out and then paste this here. That looks fine. We have that pasted. We have it here and this here. This looks fine. Let's repeat the same process for the test array. Copy this and paste out your test array. We're going to go from train split plus val split right up to the end. So we're going from 0.8 plus 0.1, that's 0.9 times total data length, from the 900th value right to the end. We'll just copy this again out here, copy that out, and then paste this for the y value. So we have this here, take this off, paste it, and then we go right to the end. So that looks fine. Again, we have now our train array, validation array, and test array. We're now set to write this information in our artifacts. So here we have with preprocessed data. This is instead now with train data. We call our artifact we just created here is train data, val data, and test data. So with train data, the new file, we have our, we'll call this train dataset.npz mode WB. Save the file, and then we are saving train. What we're saving here is actually just train array. So we're just saving this train array, and then we repeat the same process for the validation and the testing. Okay, we have that validation, test, and then here we have test, validation. Okay, we have here we have validation, and then here too we have test. Then now we log our different artifacts. So we're not only logging this one artifact, but the 3 different artifacts. Let's take this back, and then here we log train data, val data, and test data. Okay, we have that set. We could run this. Let's change it to split data. We run this cell here, everything looks fine, and then we move on to split our data. Split data, we run that cell and wait for the response. Here's the output we get. Now the reason why we're having this is because we must have integers and not floats at this level. So when we have this indices, we have to convert this all into integers. So we have this int here, there we go, int, and from here we now run this cell again and then split our data. The data has now been split successfully. Let's get back to our dashboard right here. We have our WandB dashboard artifacts. Let's refresh this page. As you could see, we have raw data, preprocessed data, and now we have the test data, validation data, and our training data. Let's click open this training data. So you could look at the file here, metadata API. We can always make use of this in creating other artifacts. And let's get to the graph view. In this graph view now, we'll be able to see the link between this original data set, the preprocessed data, and the trained data set. Here's what we get. Let's click on explode, and you can see this clearly now. So here you see you have this original data set, this artifact here. We have this run, which produces this data preprocessed artifact, and then we have this run, which produces this train data set, validation data set, and test data set. So let's draw this, take this off. We have this path here. You see we have this here. We take this, and this. Let's copy out this code right here and then start with the data augmentation. So from here we now download the train data set. We could check this out in our artifacts. You should have train data set right here. There we go. We have our train data set. We could now copy this part. Let's copy this path and paste here. Now we could click on this WandB finish to stop that run, and that should be fine. Now let's go ahead and copy out this part of the code which was used for pre-processing. So here we have this here, pre-processed data. We copy this, and then there we go. Let's paste this here. We have our augment data, and then project artifact. We're gonna use this artifact here. So let's come right here and then get this path. Okay, so we're gonna get that path and then replace this one with this on part, or the path to the trained data set. Let's space this out, and this should be fine. there's actually a file, so we have artifact file. Now we have this, take this off. Preprocessed data. Instead of preprocessed data, we're going to use augmented data. WandB artifact, augmented data set, augmented data set type, let's say preprocessed data, an augmented version of the malaria train data set. So everything looks fine for now. We have that, and then here let's get back to this and then copy out this here and then paste this right here. So we get in this from our training data, obviously. There we go, and everything looks fine. Next thing to do is do the actual augmentation and then log the data set to our artifact. So let's take this back, and then we take this off. Now we have this, we open up this artifact file right here, artifact file. We open that up, we obtain our array, let's call that array. Then for images, or for image in the array, our array O, we're taking out the X, so for image in X. Before moving on, we're gonna create this empty list here, data set X, and then we have that. Okay, we have dataset X, and then dataset X that append augment of whatever image we want to pass in. Let's send this one step, and that's fine. So for all images, we are going to do this augmentation. Then after this, we have dataset Y, which is simply the unchanged labels we've had already. So from here now, we have our dataset X and our dataset Y. Then we can now run the sol, and then we run the augment data. We have here augment data, and they should be fine. We obtain this error, preprocessed data not defined. So let's check back here, and we see that this should be augmented data instead. So let's change these, and we have augmented data. There we go. We run this source and see what we get. Now these artifacts have been logged successfully. We could get to WandB and check this out. Here we have this, and then we click on augmented data set. So loading the artifacts. Now that's loaded, let's click on this and check out on this graph. So let's explode, and then this is what we have now. So you see again that we have this path, we have our data, we separate this or split this into train, validation, and testing. You see here you have the training, validation, and testing, and then after the training we have this run, which converts this training data into an augmented data, which is this one right here. And so at this point, we have different versions of our data which we could make use of depending on our needs. Thank you for getting right up to this point, and see you next time.